All right. Hello, everyone. I will be talking about colligative properties. And colligative properties, if you can remember, pertain to that of solutions. And so, colligative property, just to go over, is basically a property of a solution that depends only on the concentration of a solute within that solution. And so these different properties can include vapor pressure lowering, boiling point elevation, freezing point depression, and osmotic pressure. So to start off with, I'm gonna just talk about boiling point increase. So basically, boiling point increase, comparing it to a pure solvent. A solution is going to require a higher temperature to achieve any given vapor pressure, including one equivalent to that of surroundings. So a solution is going to increase in temperature in order for that temperature to be even equivalent to that of its surroundings. And so that can be expressed in this equation right here. So if we have a solution and we're trying to find a change in temperature due to its solvent, we would put our information into this equation here. And so basically we have our delta T, which is just basically our change in boiling point. We have our boiling point constant, and then we have our I, which will be our moles constant. And so just to see what that looks like in an equation, so question says, what is the boiling point of a 0.33 mole solution of a non-volatile solute in benzene? So we have our equation here. We're setting it up. So this would be our boiling point constant, 2.53. We multiply it times our moles, 0.33, and we get our change in boiling point. And so to figure out what our new boiling point is, we'd add that to the original boiling point, and that would be 80.9 degrees Celsius. So whenever we're trying to find the change in boiling point, we would use this equation. So going on to freezing point depression. Freezing point depression is the decrease in a freezing point of a dilute solution compared to a pure solvent. So in regards to freezing point depression, this can be most applicable to whenever you see weather conditions get really harsh in places like Colorado, Montana, up north, where those freezing points get really, really low, and then you'd see workers go out and salt the roads. And so that salt acts as a de-icer or a freezing point depressor, because it actually lowers the freezing point even more so. And so to find the freezing point, the change in freezing point, it's the same setup of what we'd find to find our boiling point increase. And so we have our delta T, which is our change in temperature. We'd have our I for moles, and we have our freezing point constant at KFM. And so setting up our problem again in regards to benzene, what is the freezing point of the 0.33 mole solution of a non-volatile non-electrolyte solute in benzene? So we have our change in delta T here equal to our freezing point constant. So our freezing point would be freezing point constant would be 5.12 times our moles equals 1.7 degrees Celsius. And so our original boiling point is 5.5 degrees Celsius. So we would need to subtract that to see our new freezing point. And so freezing point, you can see that very evidently, like I said earlier, in regards to icing the roads and trying to get that freezing point lower. So I hope this was a brief explanation, and I hope that this helps you guys out in just going over what colligative properties are in regards to freezing point depression and boiling point increase.